Hi everyone, Mr. Markwick here. Today's video I'm going to be showing you how to use the Hungarian algorithm to solve assignment problems. Now, an assignment problem is basically allocating or assigning tasks to either individuals or something to either minimize the cost or time, for example, of the overall project, or to maximize the profit in a certain situation. So the optimal solution will either be to minimize or to maximize. There's a slightly different process for both. There's just one extra step if we're looking to maximize. Today's video, I'm focusing on minimizing the amount of time required to complete a relay race. And I have 4 swimmers here in my example: Alex, Bruce, Carl, and David, who are going to be in a relay team. And obviously they want to have the fastest time. So the times for each of those swimmers, for each of their 4 strokes for that race, are listed in this array or this matrix. So for example, Alex takes 56 seconds to swim a 100-meter backstroke, 59 seconds to swim a 100-meter breaststroke, 52 seconds to swim 100-meter butterfly, etc. And you can see Bruce's times in row 2, Carl's times in row 3, and Dave's times in row 4. So we've just put those values into a matrix here, and we want to work out which swimmer swims which of those strokes. Now, each swimmer can only swim 1 stroke to reduce the maximum time, to find the minimum time for that relay team possible. So let's just jump into step 1 here. This is the Hungarian algorithm, or the process to solve using the Hungarian algorithm. Step 1 says to subtract the smallest value in row 1 from every element in row 1. And then we repeat this for each row in the matrix, and this will give us at least 1 0 in each row. So first thing we need to do is identify the smallest value in each row. For row 1, the smallest value there is 52. In row 2, the smallest value there is 49. In row 3, the smallest value there is 51, and in row 4, the smallest value there is 48. So what I'm going to do is, starting with row 1, I'm just going to put down the new 4 values, subtracting 52 from each of those elements in row 1. So for example, I'm going to start by doing 56, take 52, which is 4. Then I'm going to do 59, subtract 52, which is 7. 52 take 52 is 0. And 53 take 52 is 1. Then move down to row 2. Now my lowest value in row 2 is 49. So I'm going to subtract 49 from each of these 4 elements in row 2. For example, 62 take 49 is 13. 67 take 49 is 18. 59 take 49 is 10, and 49 is 0. Moving down to row 3, again, this time I'm subtracting 51 from all of those values. So 55 take 51 is 4, 64 take 51 is 13, 58 take 51 is 7, and 51 take 51 is 0. Same again for row 4. This time I'm subtracting 48 from each of those 4 values. So 58 take 48 is 10. 60 take 48 is 12. 54 take 48 is 6. And 48 take 48 is 0. Now, that's step 1 complete. This is my new matrix after step 1. Step 2 tells me to subtract the smallest value in column 1 from every element in column 1, and repeat this for each column in the matrix. This will then give me at least 1 0 in each column. So you can see now each row has a 0. I want to do step 2 so that each column will have 0. So let's go ahead and identify the smallest value in each column. So starting with column 1, the smallest value there is the 4. Column 2, the smallest value there is 7. Column 3, the smallest value there is 0. And column 4, the smallest value there is also 0. So starting with column 1, let's subtract 4 from each value in column 1. So let's get my black pen back out. And I'm going to start with 4 take 4, which is 0. 13 take 4, which is 9. 4 take 4, which is 0. And 10 take 4, which is 6. Then in column 2, I'm going to subtract 7 from every value there. So 7 take 7 is 0. 18 take 7 is 11. 13 take 7 is 6. 12 take 7 is 5. In row 3, the smallest value there is 0. So 0 take 0 is 0. 10 take 0 is still 10. 7 take 0 is still 7, etc. So column 3 remains unchanged, as does column 4, because subtracting 0 will still give us the values that are already there. So that is now step 2 complete. Step 3 says to cover all zeros with the minimum possible number of horizontal and vertical lines. So I'm going to put in some vertical lines that cover those zeros. Now these vertical lines need to basically cover the whole row or column. So the first line I'm going to put in is a horizontal line here that cover row 1, covers 3 zeros. Then I'm going to put in a line here to cover column 4, covers again 3 zeros there. And now I just need to cover this 0 here. So there's, I guess, a vertical or a horizontal line I could put in. Either is fine. Let's just, for the sake of this video, put in a vertical line there. Now, at this point, if the number of lines is less than the number of rows, I go to step 4. If the number of lines I drew is equal to the number of rows, I go to step 5. I drew 3 lines, 1, 2, 3. The matrix has 4 rows. So the number of lines I drew is less than the number of the number of lines I drew is less than the number of rows. Therefore, okay, I go to step 4. It says to identify the smallest uncovered number. So let's just identify that number first, which is, in this case, 5. Sorry, let's try again. Highlight that 5. That's the smallest uncovered number. And with that number, I subtract this number from every uncovered element and also add it to every number, so every element covered by 2 lines. So these 2 numbers are covered by 2 lines. So I'm going to add 5 to both of those values. But these 6, 11, 10, 6, 11, 10, 6, 7, 5, and 6 are uncovered. So I'm going to subtract 5 from each of those values. So let's go ahead and do that. Now, get my black pen back out. So this value here, I'm going to add 5 because it's covered by 2 lines. This 0 and this 0 remain the same. Okay, so we don't touch those if it's just covered by 1 line. This is covered by 2 lines, so I'm going to add 5 to that. So 1 plus 5 takes me to 6. That 9 can stay the same. This then 11 take 5 becomes 6. This 10 take 5 becomes 5. 0 remains the same here and here. 6 take 5 is 1. 7 take 5 is 2. This 0 remains the same. 6 remains the same. 5 take 5 is now 0. And 6 take 5 is 1. And I'm then left with another 0 here. Then I go back to, once I finish that, repeating step 3. Step 3 was, remember, covering all those zeros with the minimum possible number of horizontal and vertical lines. So get the blue pen back out and cover those lines again. So 1, 2. In this case, you can see I need 4 lines. Okay, the minimum possible number of horizontal and or vertical lines I draw to cover all those zeros has to be 4 in this case, which is equal to the number of rows. There are 4 rows here. So I'm at this point here. If the number of lines is equal to the number of rows, go to step 5. So step 5 is noticing that the number of horizontal and vertical lines should now be equal to the number of rows. It is perfect. Find the pattern of zeros so that each row and each column has exactly 1 0 selected. So what I'm going to do is I'm going to remove those lines I just drew. I could rewrite it, but in fact, let's do that. Let's rewrite it. So this was then step 4 and back to step 3. If I rewrite that now, just below, so I have 5 0 0 6 9, 6, 5, 0, 0, 1, 2, 0, 6, 0, 1, 0. So now I have to identify 4 of those zeros such that each row and each column has 1 0 selected. Now this is the tricky part, but work through it systematically. Let's start with row 1. Let's go orange. So with row 1, there are 2 zeros that I could select. I could choose this one or this one. Now I'm going to choose this one here because notice that that is the only 0 in column 3, whereas column 2 has a 0 down the bottom. So potentially I could choose that one as well, but I can only choose one of those zeros in column 3 because there is only one there. So start by highlighting that one. In row 2, there is only 1 0, so it has to be that one there. In row 3, there are 2 zeros, but notice I've already selected a 0 in column 4 as well. So the 0 I'm going to choose is this one here. And that means that in the final row, the only 0 I can choose is this one here because that is the only column that doesn't have a 0 highlighted. Now, every row and every column has a 0 selected. Now, I just want to point out at this point that you can, at this point, have multiple solutions. This example, there is only one optimal solution by going through that process. There's only one way of me highlighting the 4 zeros so that there is 1 0 highlighted in every row and every column. But sometimes there's multiple ways of doing it, in which case there'll be multiple solutions or multiple optimal solutions to your problem. Now, what I'm going to do is I'm going to take this pattern here and plug that back into the original matrix with the swimmer's times. So row 1, column 3, row 2, column 4, row 3, column 1, and row 4, column 2 are the values I want to highlight on that original matrix. So let's go back to the original matrix, and we've got, as I said, row 1, column 2, row 2, column 4, row 3, column 1, and row 4, column 2. So, oh, sorry, I highlighted the wrong one at the start there. That should have been Alex doing the butterfly and Dave doing the breaststroke. So those are the 4 strokes allocated to the 4 swimmers to minimize the overall time of that team. Notice here though that as well, like with Dave, for example, his breaststroke is his worst worst stroke, but and in fact Alex's time is better, but overall this is the optimal solution. So the question will then go on to say pretty much, you know, what is the minimum optimal solution, or what's the minimum time that the swimmers can do this medley. In this case, I'm adding those 4 values together. It's going to be Alex's 52 seconds for the butterfly, Bruce's 49 seconds for the freestyle, Carl's 55 seconds for the backstroke, and Dave's 60 seconds for the breaststroke. Okay, so each of those swimmers is now allocated 1 stroke each, and those 4 times will give me the overall time for the relay team, hopefully. Okay, so that's the process to find a minimum optimal solution using the Hungarian algorithm. In my next video, I guess what I want to work through is a maximization problem, and then I'll do another video where we have non-square matrices where we need to add a dummy row of zeros or a dummy column of zeros to make it a square matrix. So notice that the questions will generally be given to you in a square matrix, so a 3x3, a 4x4, a 5x5, a 6x6, and if they're not, then there is a different process, just that initial step. But again, I'll do a video on that soon. So hopefully that helps, and thanks for watching.